Magnets. Introduction. A piece of iron which attracts other pieces of iron, nickel and cobalt, is said to be a magnet. Magnet occurs naturally in the earth as stones of iron oxide. These stones are called lodestone. The first magnet was discovered in ancient city of Magnesia, where it was called magnetite. Magnet attracts iron objects and aligns itself pointing in the north-south direction of the earth. This phenomenon is called magnetism. History of magnets. It is said that there was a shepherd named Magnus who lived in ancient Greece. He used to take his herd of sheep and goats to the nearby mountains for grazing. He would take a stick with him to control his herd. The stick had a small piece of iron attached at one end. One day he was surprised to find that he had to pull hard to free his stick from a rock on the mountainside. It seemed as if the stick was being attracted by the rock. The rock was a natural magnet, and it attracted the iron tip of the shepherd's stick. It is said that this is how natural magnets were discovered. Such rocks were given the name magnetite, perhaps after the name of the shepherd. According to early Chinese, when an iron needle was rubbed on lodestone, it also got magnetized. Chinese even found that when a magnet was freely suspended in the air, it always pointed in north-south direction. This is what led to the discovery of a magnetic compass. In his great study on the magnets, D-magnets, William Gilbert explained that the compass pointed in north-south direction because the earth itself is magnetic in nature. This is what led to the study of modern physics and astronomy. Magnetic and non-magnetic substances. Those substances which are attracted by a magnet are said to be magnetic, whereas the things which are not attracted by a magnet are non-magnetic. Some magnetic substances are iron, nickel, and cobalt. Substances like copper, aluminium, gold, and tin are non-magnetic. Iron is a soft magnetic material because it can be easily magnetized. It even loses its magnetic properties easily. Steel is a hard magnetic material because it is difficult to magnetize, but it does not lose its magnetic property easily. Types of magnets. There are two types of magnets. Temporary magnets. They retain their magnetic properties only for a short period of time. They are usually made of iron, cobalt, and nickel. These materials behave like a magnet only when they are near a strong magnet. They quickly lose their magnetic property if the influence of the strong magnet is removed. Permanent magnets. They retain their magnetic properties for a very long period of time. They are made from a mixture of iron, cobalt, or nickel with other materials. These make strong magnets and retain their magnetic properties for a long time. Scientists have been able to find methods of making magnets from pieces of iron. These man-made magnets are known as artificial magnets. Artificial magnets are made in many different shapes, like a bar magnet, a horseshoe-shaped magnet, a dumbbell-shaped magnet, a ring-shaped magnet, and a needle-shaped magnet. All these differently shaped magnets find utility in different objects of daily use and scientific use. Poles. On freely suspending a bar magnet, it is observed that it always comes to rest in north-south direction. The pole of the magnet pointing towards the geographic north is called the North Pole, and the one pointing towards geographic south is called the South Pole. Magnetic power. Maximum iron filings cling on the two ends of the bar magnet. This shows that the two ends of the magnet have maximum magnetic powers. The magnetic power of a magnet is maximum at the poles. Place the magnet in a stirrup made of copper wire and suspend the stirrup using a thread as shown in the figure. Make sure that there is no magnet or magnetic substance nearby, otherwise magnet will be attracted towards it. Magnetic poles always exist in pairs. If we cut the magnet into two, we cannot isolate the North Pole and the South Pole. Instead, we will end up with two separate magnets each, with its own North Pole and South Pole. If we further cut these two magnets, we would get four separate magnets, each with its own North and South poles. So we can conclude that poles always exist in pairs. We can never have an isolated North Pole or South Pole. Attraction and repulsion. Suspend a bar magnet in north-south direction. Now, bring the North Pole of a bar magnet, whose poles are already known, near the North Pole of the freely suspended magnet. What do you observe? The magnets repel each other. Now, we repeat the process by bringing the South Pole towards the North Pole of the suspended magnet. We observe that they attract each other. Thus, the conclusion is that like poles of a magnet repel each other, while the unlike poles attract each other. Take a plastic or a paper cup. Fix it on a stand with the help of a clamp as shown in figure. Place the magnet inside the cup and cover it with a paper so that the magnet is not visible. Attach a thread to a clip made of iron. Fix the other end of the thread at the base of the stand. Mind you, the trick involved here is to keep the length of the thread sufficiently short. Bring the clip near the base of the cup. The clip is raised in air without support, like a kite. Making a magnet. With the help of a permanent magnet, you can change a piece of iron into magnet. There are several methods of making magnets. The simplest one is called single touch method. Take a rectangular piece of iron. Take a bar magnet and place one of its poles near one edge of the bar of iron. Without lifting the bar magnet, move it along the length of the iron bar till you reach the other end. Now, lift the magnet and bring the pole, the same pole you started with, to the same point of the iron bar from which you began. Move the magnet again along the iron bar in the same direction as you did before. Repeat this process about 30 to 40 times. Then bring a pin or some iron filings near the iron bar to check whether it has become a magnet. If not, continue the process for some more time. Remember that the pole of the magnet and the direction of its movement should not change. Magnetic compass. Magnetic compass is a device based on the direction-giving property of a magnet. A magnet, when suspended freely, rests in the north-south direction. This property is being made use of in this device. It contains a magnetic needle pivoted on an axis in such a way that it can rotate freely. The needle is painted red on the North Pole side. The entire setup is placed in a small cylindrical box of brass. In the rest position, the needle points in the north-south direction. The magnetic compass is a great help in finding out the directions. Handling magnets. While handling magnets, we should be very careful. We should never throw them. We should not hammer them. Heating of the magnet should be avoided. Magnets should be stored with magnetic keepers. Magnets should be kept away from cassettes, mobiles, televisions, music system, computer and CDs. Uses of magnets. To separate iron or magnetic substances from non-magnetic substances in industries. In electric motors, which are used in fans, coolers, mixers and so on. Video and audio cassettes contain a reel of magnetic tape. The audio and video information is enclosed on the magnetic coating of the tapes. Credit, debit and ATM cards have a magnetic strip which contains the necessary information about the account. Speakers and microphones of all sound-producing devices have ring-shaped magnets in them. Magnets are also used in transformers. Small magnets are used to treat different diseases in humans.